Welcome to Advanced Java Programming at Portland State University. In this screencast, we're going to talk about the foundations of the web and how to work with the web and develop web applications in Java. So it should come to no surprise to anybody, since you're watching this on YouTube, that the World Wide Web is the primary means of person-to-person electronic communication, period. That's it. Now, most of the data on the web is delivered via HTTP, which you've probably seen in your URLs, but maybe haven't had a chance to really dig into in detail. Well, HTTP is the Hypertext Transport Protocol, and it provides the underlying protocol, the underlying language in which data is sent over the web. Now, Java, the Java programming platform, has a series of APIs called Enterprise Java, which is all about developing applications that are accessible via the web. It talks about technologies for the front end, tools for building web content, whether it be HTML or XML, and then also talks about what happens in the middle tier, how business objects are maintained, and then also things that happen in the back end, working relational databases. In this discussion, we'll just touch on the web-facing parts of Enterprise Java and look at some of the foundational technologies for working with the web in Java. So, what we're going to talk about? Well, first, we're going to briefly discuss how the web works. Then we're going to talk about how you write web applications with Java. And then we'll finish with a discussion of developing web services that are RESTful. Okay, so how do I explain the internet? Well, we'll start with the explanation that former Alaska Senator Ted Stevens gave back in 2006. The internet is not something you just dump something on. It's not a big truck. It's a series of tubes. And if you don't understand, those tubes can be filled. And if they are filled, well, when you put your message in it, it gets in line, and it's going to be delayed by anyone that puts into that tube enormous amounts of material. Enormous amounts of material. Yes, exactly. When I think of the web, I have a sort of a picture like this. There's my machine. I'm running something like a web browser on it, and it talks HTTP over the internet. And then that gets routed off to some remote machine, which is running a web server that by default speaks on port 80. Okay, let's take a deeper look at HTTP, the Hypertext Transport Protocol. So this is the protocol that's used to communicate data over the web. So if you go off and read the RFC, which is the sort of formal specification of all of this, you'll see that it was originally designed to send hypertext, right? HTML or something that links documents to other documents between a server that hosts the document, and a client browser, which is known as a user agent, right? I mean, you don't have to have just a web browser as a client. You could have a command line utility or some other tool. So by default, the HTTP communicates over port 80, and this is the port over which the agent makes the requests and over which the server serves up content. So if you look at an HTTP request, it has several parts. The first line of an HTTP request is what's called the request line, and it's something like get, which is the verb. We'll talk more about that later. The server, www.px.edu, and then some resource, some file on there, /index.html. Then there's a section of key value pairs that provide header information about the request, such as the date that it's being made and maybe the host that it's going to, things like that. There's an empty line, and then an optional body to the message that contains data that is sent to the server. And we'll see that different kinds of requests, different verbs, will or will not send data in their message. And so each one of these lines is separated by a carriage return line feed character. So that's just the way that the standard works. We're going to write a Java program that makes an HTTP request. Before we get to that, I want to go over some very basics of working with networking in Java. There's a package in the JDK called java.net, and this is a package for doing networking. It's got classes and interface and exceptions that are all related to networking. In particular, there's a class called socket, which is used to send and receive data communicate with another machine using TCP, the Transmission Control Protocol. Now, when you create one of these sockets, you give it the name of the remote machine and a port on which the remote machine is listening. Once the connection happens, so as you can imagine, there's lots of lower level stuff that happens beneath that socket. But once the connection has happened, you read and write bytes from that socket. And the way you get at those bytes is by using, well, our old friends, Java I/O output stream to send data, and Java I/O input stream to read data that came from the server. So, this is a good example of where the authors of the Java APIs reused concepts that already exist, things like input stream and output stream for working with sockets. And as we talked about in the core API lectures, because the same interface, well, actually in this case, same abstract class, output stream and input stream, because they're reused, you don't need to learn new APIs. You can just work with them as the same way that you did input streams and output streams for files. Okay, here's some Java code for sending a request to a web server. So we have a method get HTTP, and you give it a host, a port, and a file to get. First thing we need to do is make a connection to the remote machine. So we create a socket from giving the host and the port. And by the way, note that this exception, I/O exception, is may be thrown. So if anything goes wrong here, an I/O exception is going to be thrown. If the if the machine is successfully connected to, the socket will be created. And then what we want to do is, we want to be able to write text to the socket and then read text from the socket, right? HTTP is a text-based protocol. Well, how do you read and write text in Java? You use the reader and the writer APIs. So from the underlying socket, we'll get the output stream, wrap an output stream reader around that, output stream writer around that, and now we have a writer for writing text to our socket. Similarly, we will get our input stream for our socket. We want to read text from it, from the socket, and we'll wrap an input stream reader around that. Okay, so now we want to send our request to the server over the socket. So we'll simply write to our output stream, which is really wrapped around, our output writer, which is wrapped around the output stream that came from the socket. We'll say on the first line, get the file that was requested using the HTTP/1.1 protocol. There's our line delimiter. We'll set the host header. Then we'll have two empty lines to denote that this is the end of the message. And then we'll flush, and that will write everything out to the socket. Now what we want to do is we want to read the response. So we'll create a buffered reader around the input stream reader, which will read from the input stream from the socket, and we'll sit there and read each line of the response while there's more stuff to read, and then we'll close it out. So now let's run this program and see what it looks like. HTTP get, and we'll have the server web.ccs.pdx.edu, and we'll have the file /index.html. Okay, so let's take a look at what this returned. This first line here is telling us that, okay, we are dealing with HTTP version 1.1. The 200 is the status code of the request, and 200 means, well, everything was okay. So whatever it was I asked for, it was able to process the request and return it correctly. The same way that the HTTP request has a header that has these key value pairs that describe the request, the response comes back with a bunch of key value pairs with things like, okay, here's the date it was processed on, here's what version of the server, running Apache on Ubuntu, when the last time the file was modified, and well, actually, this one's kind of important. The content type, which says, okay, the type of the content that will follow will be text HTML. This is the MIME type. This is how it's encoded. We'll talk a little bit more about that later. And then, okay, now it's got the body of the HTML file all right here. So there's the doc type, there's the beginning tag, and you can just sit here and read this to your heart's content. Of course, just reading it all as text is not actually going to render it as HTML. Yep, there's an example from the slides. And yep, there it is. Okay, I want to dive into a little bit more detail about those status codes. So remember, the first thing that the server returned was a status code saying, "Hey, was your request successfully processed?" There are a bunch of different numeric codes, and each sort of series, the ones that begin with the same digit, the 100, 200, 300, 400, 500, etc., are all sort of similar. So if you get a 100, something in the 100 series is called informational, meaning that the request is still being processed. 200, ones in the 200 series are successfully processed. So 200 is what you see a lot. Okay, yep, that's okay. But you also have variations on that, like 201, which means it's created, and 204, which means there's no content. The 300 status codes all have to deal with redirection, that that's someplace else. So 301 means moved permanently, 302 means found in another location, and you can in the headers of the other responses, you'll be able to find out where the new location is. 400 series indicates an error on the client side. So, for instance, 400 is a malform request. 403 means forbidden; you don't have permission to do it. And then 404, which I'm sure everybody's seen, means that the resource wasn't found. You went in to ask for something that doesn't exist. And then 500 means that there's an error occurred on the server side. So you try to make a request and the server ran into some problem, so you get a 500, or there are more specific ones like 501, not implemented, or 503, service not available. Okay, so how do you locate things on the web? Well, you use a URL, right? This is sort of like, Web 101. Well, a URL, a Uniform Resource Locator, really talks about the location of some resource on the web. Notice I don't say web page or file, really something more abstract. It's a resource. So here's an example of a resource for resource URL for doing a Google query. And so what are the parts of it? Well, there's first of all the scheme, which talks about the protocol that's used when you want to interact with a resource, something like HTTP. Then there's this hierarchical part of the URL that identifies the path to the resource. And for HTTP URLs, it's the host and port of the machine, and then the location of the resource, if you will, on that machine. And here again, URLs are more generic than just HTTP. There may be other ways of locating it. Think about a file URL. It doesn't have a machine name, right? It just has the path to the file. There's after the question mark, there's an optional query, which are key value pairs that are tacked on to the URL. And they don't have an example of it here, but after a pound sign, a hash sign, is the fragment, which is really direction to a secondary resource. So in HTML, this is interpreted as an anchor to within the HTML document. But really, you're free to interpret it however it is you want. The spec, the URL spec, or the HTTP, the URL spec doesn't say how it has to be used. We've seen this a couple times now. Now we're going to dig into the details of the URL class in Java. So there's a class called URL in the Java.NET package that represents a URL. If you go and look at the API, you'll see the constructor is overloaded to take all sorts of different things. That you can specify the protocol and the host and the port, which file you're looking for, etc., etc. Once you get one of these URL objects, if you invoke the OpenStream method on it, you'll get an input stream for reading the resource. And so the implementation of URL and the input stream take care of all the details about making the call off to the server and interpreting the response, everything like that. If you want to do some more advanced stuff with the URL, so for instance, not just fetching data to it, but maybe sending data, posting data to an HTTP URL, you use the open connection method. Now, open connection returns an object called URL connection that lets you interact. And if you are working with a URL with the HTTP protocol, you can cast what's returned by that open connection to an HTTP URL connection. And this HTTP URL connection object allows you to do things like set the headers for the request and which request method you're using. Is it a put? Is it a get? Etc. etc. And you can also get an output stream that you can use to write to the resource. If you look at the API documentation for HTTP URL connection, you'll also see constants for all of the HTML status code. So this will make your code easier to read, right? And so instead of saying, if status code equals 404, you say if status code equals HTTP underbar not found, something like that. Okay, here's another implementation of getting a URL, but instead of using sockets, instead of using sort of the lowest level programming mechanism in the Java API, we're going to use the URL class. So here, instead of the host import and everything, we're just going to get some arbitrary URL, and we'll get in the string. So what do? We create a new URL from the string. Oh, and by the way, if something goes wrong, it'll throw an IO exception. Once we have the URL, we'll simply call open connection. This will return us a URL connection, which will cast to an HTTP URL connection. We'll say that, hey, I want to do a get request of this URL and call connection connect. Then we're going to print what's the response back to our request to standard out. So first we'll print out the headers. Then we'll call the get header fields method on the URL connection, which returns a map of strings to a list of strings, which are all of the header key value pairs, and we'll simply iterate over them and print them out. This is a lot of formatting in here to sort of make it look nice. And then we'll print out the content by getting the input stream returned by the connection and wrapping an input stream reader and a buffered reader around that, and then reading every line of it and closing it. I don't know if this is necessarily fewer lines of code, but it sure is the API that's provided by URL and HTTP URL connection is a lot nicer, right? You can sort of get the header fields instead of just having to parse all the text yourself. Someone who's probably smarter than you are has already written code, and it's definitely been tested better than anything that you've written. Okay, let's run this class again. URL, and now we'll just have http web.ccs.pdx.edu/index.html. Okay, here are all the headers. Well, here's the first line of the header, but here are all the key value pairs. Yep, and here's the content again. Good deal. Okay, well, that worked out pretty well. So anyway, so here are these are some of the examples of the APIs that standard Java provides for working with URLs in HTTP. Okay, I wanted to go into a little bit more detail about these various request methods. So the HTTP specification defines various methods, not to be confused with Java methods. These are methods of HTTP that determine, well, basically what you're doing with that resource. So there is a method called get, which simply fetches the resource from the server. There is a method called head, which is like get, but only fetches the headers, not the content. There's post, which submits data to the resource body, and then there's put, which uploads content to the resource. So post is sort of like asking the resource to do something, and put is setting the content of the resource. And then there's delete, which deletes the resource. There are a handful of other standard methods that are defined. Things like a trace, which will return the request in the body of the response. So basically, you sort of like make sure that you can go all the way from the client to the server and back. Options, which returns a list of methods supported by the server, and this thing called connect, used with SSL tunneling. I have to be honest, I've never used trace, options, and connect. I didn't even know they existed until I went and read the spec. Let's spend a little bit of time talking about how Java works on the server side. We saw some examples of writing HTTP clients using Java. Here's how things work on the server side. So, as I mentioned at the beginning, there's something called Enterprise Java, which is about defining these technologies and these standards, these APIs, for developing large multi-tier applications. Things with a user interface in the front, business middle in the middle, business logic in the middle, and then database storage on the back end. Sort of the fundamental unit of web development is something called a servlet. It is, think about it, a little server within a server. It's a Java class that handles HTTP requests. Fundamentally, that's all it is. So you have these special classes which know how to handle HTTP requests and do something depending on what the request is. And you bundle all of those together with other Java classes, right? All your application logic to then support what you do these requests, and likely some static content, HTML pages, images, whatever. And it's something called a web application. So all this stuff is bundled into a web application, and then it is deployed into something called a web container, which is essentially a web server that's almost always written in Java that knows how to deal with these servlets. And what the job of the web container is to do is to act like a web server, and so it responds to requests, usually on port 80 or port 8080, routes them to the appropriate servlets, and then will send the response generated by that servlet back to whoever made the request. And when you configure the web applications within a web container, you map a certain part of a URL, the prefix of a URL, off to some servlet, and it's up to the servlet to do the rest of the heavy lifting. So servlets are fundamental. They are comparatively low level, but they're what I want to talk about in this discussion here. So this will not be about writing pretty HTML or really having any framework on top of servlets. You might have heard things like Java Server Pages or Java Server Faces. When we talk about Google Web Toolkit, we'll see that it too leverages servlets. But all that stuff is written on top of servlets, and that's probably what you want to use when generating HTML pages. Otherwise, you're just writing HTML in Java source, and it looks awful. Not that it looks that great in those other technologies, but we'll see some examples of that later. Okay, here's a picture of the servlet architecture. So here again, you've got your client machine and your server machine. You've got a web browser that goes and makes some request to your web server. And so here you're running, on your server machine, you're running a web container inside a Java virtual machine. And the job of the web container is to go off and route various requests to the appropriate web applications. And then within the web application, it can further route requests based on URL mappings, URL prefix, to the appropriate servlets. So for instance, here, when I have a request of, localhost, if it's running locally, 8080 if that's the port, site, store, books. Site will first go to the site web application. Store will then go to the store servlet. And instead of your store servlet to understand, what does it mean when you ask for books? We can imagine that there are other servlets and even other web applications that handle different requests. So the nicest thing about the web container is the web container and the Servlet API is that it provides an abstraction over all of these details of HTTP. Right, I mean, it's conceivable that you could go read the HTTP spec and implement your own web server, which maybe would be a neat academic exercise. But really, the web containers have been around for a very, very long time. They've gotten very good at what they do, and so hey, let someone else do the heavy lifting. You can focus on writing your application, the servlets that make sense to you. Let's look at some of the APIs that are provided by the servlet. So there's a very generic abstraction that's sort of like, hey, highest level servlets, you get things like generic servlet, which basically all it knows how to do is process some kind of request. The more interesting one, or at least more relevant to this discussion, is HTTP servlet. The container, the web app, the container provides an object called Servlet context, which describes the web application itself, and we'll see what's available through these APIs in a little bit. There's also some lifecycle callbacks that you can register with your web application. So things like, hey, every time something about the servlet context, the web application itself changes, let me know. Or probably more interesting, hey, every time there's a request, call back a certain method. And you can use this for things like authentication, making sure that the user that is making the request is logged in and probably has the right permissions. You can also use it for, tracking your requests, figuring out what URLs are being hit most often, and how. And the nice thing is that you can register this listener on the servlet context, and your application doesn't need to know anything about that. Anyway, there's some, maybe that URL is out of date, but here you can go and find the docs online. Okay, the HTTP servlet object itself has do methods for each HTTP request. So do get, do post, do delete, etc., 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 etc. And then in what you do is you subclass HTTP servlet to then override the methods that you care about to do the things that you care and want it to do. So here is an example servlet. This this servlet basically spits out all sorts of information about the request that was being made. So I'm going to call it servlet info servlet because it provides info about a servlet. And it extends HTTP servlet. So it overrides the do-get method. So when you send it a get, it's going to do the following. The do-get method has two parameters, HTTP servlet request and HTTP servlet response, which are objects that model, the request made by the client and the response send back to the client. If something goes wrong, you can throw a servlet exception or an IO exception. Okay, so what are we going to do? Well, first we're going to do a little bit of configuration of the response before we start writing content to it. We're going to say, okay, this is encoded as text HTML, and the buffer size is going to be 8K. After we do the configuration, we go and get a writer object. So it gets a print writer, right? Our old friend Java IO print writer, nothing special here. And we're going to write a whole bunch of HTML to it. Here again, this probably isn't best practice, but it's a good first servlet to work with. So we'll spit out some HTML, and then we'll go generate more HTML to describe the servlet config, the context, the request that was made, etc., etc. I don't think I go through I'm not going to go through all the details here, and then write out the end tags to the HTML document. I'm going to quick walk through what's available in the API, and then we'll actually run the servlet, and we can see what the kind of values are. So what's available in HTTP servlet request is information about the request that the client made. Well, you can get all the HTTP headers. So you can just get a header as a string, but it also has support methods for, hey, give me it as a date or give me it as an int. Information about the URL that was requested. So like what the query was or what the entire URL was. And you can imagine that your servlet then would want to interpret certain things or act according to what's on the actual HTML that was requested. Information about the user that was logged in. So web containers provide support for managing authentication. And so you can get things like, okay, what's the user principal? What's information about the username of the person who's logged in? There's also something called a session, which we'll come back to in a little bit. The request also lets you get the key value pairs that are in the query string as so-called parameters, and so you can ask for the value of a parameter by its name. And then the application itself can also hook on its own key value pairs as attributes. So Parameters come from the client, from the user, if you will, of your program, but attributes are used internally to the request. So, imagine that processing your request is kind of like a pipeline, right? So you might have, things that, okay, first I'm going to authenticate to make sure that the right person's logged in. And then, I don't know, I'm going to, set some application context based on where I am or what time it is, or, oh, maybe this is a special customer. Well, you can annotate, you can augment the HTTP request by setting attributes. And then, of course, you can get information about the body of the request, the content that came in the request, as an input stream. If you expect it to be binary, so for instance, if you're uploading an image or something, and get reader if you're posting some text, and of course, you figure out whether or not you have an image or text or whatever based on the content type of the request. The response goes the other way. It configures the response sent back to the client, so you can get you can set the headers for the response. You can set the status code, right? You can say, okay, yeah, this is a HTTP 200, everything's okay, or oh, an error occurred, and here's the error that I want. Notice that there are constants in the HTTP Servlet response class for all of the error code. So here's a place where there's duplicate information inside the Java API. There are status code constants for both on both the servlet response and the HTTP URL response. Meh. The servlet response, the HTTP servlet response, also has methods for easily redirecting the user agent to another URL. This will send back the appropriate, 300 response. And then, of course, you can get at the body of the response. This is what we did before, right? We said the content type of the response, and then we got the writer so that we could then write our text back out to it. Now we've seen an example of a servlet and some of the APIs available to the servlet. But before we can actually run this servlet, we need to put it inside a web application. So here I said the web application is a sort of conglomeration of different files. You've got your servlets, you've got some supporting Java code, you might have some static content like HTML files or whatever. And this is all configured in a configuration file called web.xml. And web.xml has all sorts of stuff. You can configure information about the web application itself. Oh, an icon that should be displayed by it, its name, description, stuff like that. You also configure these callback objects, things like configuration of the servlet context itself, of the web application itself, the filters that you want to use, and then also any listeners for like request listeners for the requests made to that web application. You also specify what the servlets are in that web application and how to map URLs to those servlets. And then some default content like here's the error page that I want. This is all explained in the XSD for the web.xml. Here's an example. It's XML. I know it's hard to read. But here you start out with a web app tag. Say here's the display name. Here's the servlet. Here's a description of a servlet. So here's how we deploy our servlet info servlet inside our web container. So you can give it a name, and also a display name, a description of it. Probably the most important thing is here in the servlet class is the fully qualified name of the class. And you can also initialize the servlet with some key value pair parameters. So this is yet another set of key value pairs that are available to the servlet. So you can imagine that you might have the same servlet reused in different web applications, but they might be configured differently. So let's say that you had a servlet that was very good at serving up images or something like that. You could use an init parameter to configure the file on the file system on which the images reside. That file will be different for every time for every deployment of that servlet, but the servlet would still do the same thing. Finally, you've got to map your servlets off to URL patterns. So here we have the name of the servlet, which is what we specified up here. We said, okay, that servlet is going to be mapped to /info. So now, after we deploy our web application and we browse to a URL like localhost 8080 web/info, we should see the result. That will get routed to the web application. And you know what? Let's just take a look at that. going to skip ahead a little bit here. Don't worry, we'll come back to talk about what all of this means. I'm going to start my web server, and that's going to deploy the application. Okay, looks all good there. Now I'll go to my web browser. Put up a new tab, localhost 8080 web info. So now it hit that servlet that printed out all of the information about the servlet and the servlet request, and here it is. So servlet information. Here's today's date. Here's the information that's available in the servlet config. The name of the servlet config, of the servlet is servlet info, and it has a init parameter called param1 with the value of hello param, and this was specified here in the web XML, right there in this init param. And again, these init params can be used to configure your servlet different for multiple deployments. Here's all the information that's available inside the servlet context. You've got the name, the version of the server that's being run, all sorts of attributes, etc., etc. Nothing terribly relevant, but it's available to you if you want to do something different based on it. I think what's most interesting is the HTTP servlet request itself. It's interesting that the content type is coming across as null. But you can see here's the port that was made on. Oops, here's the port that was made on. Here's the locale that's used for the encoding. This is a get method. Here's the scheme. Here are the headers. So here again, the host, the description of the user agent. And some stuff about cookies, and we'll look at that later. But here's also the URI. So actually, I wonder what would happen if we then tack something on let's tack on a parameter like a equals b. Reload it again, and now I think here's the query string a equals b. And I guess I don't explicitly call it out, but there are nice APIs for, oh no, there it is, parameter A. So here's the parameter A equals B, and let's add something else, C equals D. This is profound stuff here. Yep, so here are my parameters. So remember, all of this ugly table was generated by invoking methods that are available to the Servlet API. So then you can imagine how in your servlet you can then invoke those same methods to get information and do something much more interesting with them than just print it all out to a table. Okay. Web application archive. So again, I told you this web application is this combination of all sorts of different files and things like that. Well, all this gets bundled into something called a web archive, or a WAR file. It's basically a jar file with special stuff in it in special places. So your web XML file resides in a directory called web-inf. You put all of your server-side classes in there, and you put any jar files that are needed on the server side. So if you're using, if you're using like maybe one of my classes or something like that, you can put my jar file in there. And again, all of your static files, your HTML, JavaScript, whatever you need that are used by the application. So if you, like I said, these WAR files are just jar files. So if you then go look at the contents of them, you'll see that there's HTML files in there. There's your web XML. There is your classes. There are jar files. All sorts of good stuff. Okay, I think I've talked long enough about web applications and working with the web in Java. I want to stop here, but next time we'll pick up and see how Maven works with web applications, and then also discuss REST, the representational state transfer. So, as always, thank you for watching the Advanced Java Programming Screencast from Portland State University.